Just to introduce my research, I'm looking at therapeutic tape and how it affects both pain and muscle function, and so I set out to use tensiomyography for the pain element of my research over the 3 to 4 years. So when I started, I got given the tensiomyography equipment and I didn't know how to use it. I just knew that I had to use it because I was told to. And so when I went through the training, there was a lot of variation in that we've seen where you can place the probes, how exactly to place them, what times to use in between consecutive stimulations, and this was evident in the literature as well. So I started by just doing a look-see really to see what effect these parameters would have on my results on my therapeutic tape, because I wanted to make sure that any effect that I did see was due to my tape and not due to the measure protocol that I was using. So the investigation was to look at how stimulus amplitude, inter-electrode distance and interstimulus interval had on maximum displacement and muscle contraction. And we've seen earlier today that DM and TC, which are displacement and contraction time, are the two measures that we do use most commonly. So this is why I've used them here. Again, already seen this, so how it works, just a reminder. So it is just measuring muscle displacement ultimately, and then from its displacement we can look at contraction time. So you place the probe at the muscle belly and you compress it into the muscle, and when the muscle contracts radially, moves the probe, and then we can measure the time of that contraction. And this is a typical output. So you're looking here at displacement in millimeters on the y-axis and time on the x-axis, and I'm interested in maximum displacement, which you can see at the top, and then contraction time. And the contraction time is calculated at 10% of maximum contraction to 90% of maximum contraction. So my research, the aim was 3-part. So first of all, I wanted to look at if the amplitude required to achieve maximum contraction changed if I did this multiple times. So in a lot of the intervention studies, you're looking at a baseline score, then you're giving an intervention, whether it's tape or running, and then you're going to measure afterwards as well, or during the intervention if you can do so. So I wanted to see that if I got to maximum contraction before and after and I saw an effect, is it my tape or is it just the repeatability of the technique? And I was looking at the coefficient of variation between the amplitude required 3 times within an hour to get to maximum contraction. So in a wordy version, there we go. The next part was to look at inter-electrode distance. So I wanted to vary the distance between the electrodes on the rectus femoris and see if it had any effect on displacement and contraction time. And then likewise with the interstimulus interval time, again I'm going to vary the time between consecutive stimulations and see if it affects displacement and contraction time. So this is the method for the first study. So this is the one where we're looking at the amplitude required to achieve maximum contraction. You can see here, this is one block. So I did do stimulations before 40 milliamps. I actually started at 20, but here I've just put on 40. And I stimulate every minute, so I'm leaving a really long interstimulus interval between consecutive stimulations here. And then a nice washout period in between. So I'm stopping anywhere in here when I'm getting to maximum displacement, giving the washout period and repeating the whole process. Okay, so here are the results. So we've got an N of 10 in each group. And so each row is a different participant, and each column is each round of the getting to maximum contraction. So, for example, with the first participant, they got to maximum muscle contraction at 60 milliamps. Then we've got the mean standard deviation of this data and the coefficient of variation for each individual. And the mean for all of this data here is that we've got a coefficient of variation of 5.7%, which is considered low. So that's good. The next study is looking at inter-electrode distance. So we've, in this circumstance, kept the stimulation amplitude the same all the way through. We've got big washout periods here. So I should say in the literature, most people are using between 10 and 15 seconds between stimulations. So 2 minutes is quite big. And then we've looked at 5 centimetres, 7, 9 and 11 centimetres. So it should be said that in all cases, all of the participants received every single condition in this order. So we started at 5 and ended at 11. And this is what we found. So here we're looking at displacement versus intraelectrode distance. And each line is an individual participant, and the solid line here is the mean information. And we saw that there was a significant effect on displacement between 5 centimetres and 7 centimetres, which if I hadn't done this and I was using an eyeball technique just to get to the muscle belly to stimulate the muscle, that could have shown up as a significant effect for my therapeutic tape. So that was quite important within my research to know. So the final study was the effect of interstimulus time on displacement and contraction time. So in this scenario, we're looking at 30 seconds, 10 seconds and 5 seconds. And again, everybody got all conditions. And we've got 10 repeated measures with the specific interstimulus time. And a nice washout period in between the two as well. And this is what we found. So here we're looking at displacement versus interstimulus time. And again, same setup where we've got each line is a different participant and the mean data is here in the solid line. And we found there was a significant effect on displacement when using 10 seconds over 30 seconds, which again, for my research when I'm looking at an intervention is important if I'd been using the 10 seconds, which is quite popular in the research. And then when we also look at how stable the measures are over time, so this is the measure number 1 to 10, and we're looking at contraction time here. And you can see that the most stable interstimulus time over time is 30 seconds. So the major findings from this research is that the mean of the within subject variability for the amplitude required to get to that maximum contraction 3 times within 1 hour, 1 hour is a usual experimental time in our research, is 5.67%. We are getting a stronger muscle contraction when we use 7 centimetres distance between the electrodes compared to 5 centimetres. And we're also getting a stronger muscle contraction. Here I'm talking about muscle displacement when I'm using a 10-second break compared to 30-second break. And that 30 seconds is giving us the most stable result in contraction time over if you're doing a repeated measures experimental design, which is what I often use. Okay, so the future work off the back of my study was that Ash and I are going to be looking at intraelectrode distance on more muscle groups. So we're going to be looking at the biceps brachii, the biceps femoris, gastroc and the glute max. And again, we're just going to be varying the intraelectrode distance. So that we've got ethical approval for this. We'll be starting probably in September now. And the next study on my PhD will be using tensiomyography to look at the effects of therapeutic tape, which I've already mentioned, on pain and muscle contraction. And this is going to be in a delay onset muscle soreness study. So if anybody wants to participate, please let me know. That would be excellent. So yeah, my thank yous are to my supervisory team. So this is Peter Francis, Dr. Peter Francis and Professor Mark Johnson. And that's definitely the end. Thank you.